In this example, we have y equals x cubed, x equals 1, and y equals 0. So we're talking about the region that's bounded by these three equations, and we're rotating that region about the x-axis. First, we have y equals x cubed, so that's this graph right here. Then we have x equals 1, which is the vertical line right here. And then y equals 0 would be right here, the x-axis. So you can see you have your shaded region that's bounded by those three curves. And again, we're rotating around the x-axis, so I just drew a little axis of rotation arrow right here. To draw your R, you start on the axis of rotation, you draw it perpendicular to that axis, and you draw it towards the shaded region. Since R corresponds to this curve, y equals x cubed, I'm going to write that over here on the right. We're rotating around the x-axis, which is a horizontal line, so this is going to be a dx problem. So we look at the shaded region, and in the x direction, the shaded region exists from 0 to 1. So that's going to be our limits. So we're going to go the integral from 0 to 1, and then pi r squared dx. And again, since r corresponds to the curve y equals x cubed, we're going to fill in x cubed right here. At this point, I'm going to pull the pi to the front, and then x cubed squared is going to be x to the 6th, and we're ready to integrate. The integral of x to the 6th is 1/7 x to the 7th. So I'm going to pull this 1/7 to the front, and now we're going to plug in 1 minus plugging in 0. So our final answer is pi over 7. For this example, we have x equals the square root of 5y squared. We have x equals 0, y equals -1, and y equals +1. We're going to take the region bounded by these curves and we're going to rotate them around the y-axis. Since this says x equals and the y is squared, it's going to be a parabola that opens to the right because this square root of 5 is positive. And because there's no values at the end or any other values with x, that means the vertex is at 0, 0. So I drew this parabola right here. Again, vertex is at 0, 0. It opens to the right. Then we have x equals 0, which is this line or the y-axis. Then we have y equals +1 and y equals -1. So your shaded region is right here and right here. And then I did the arrow of rotation right there just to indicate that we're rotating around the y-axis. And then next, to draw the R, you always start on the axis of rotation and you draw a line perpendicular to that axis and you draw it towards the shaded region. And again, I want to point out that R starts on the y-axis and it goes a generic distance out to the right. And R corresponds to this curve, which is x equals the square root of 5y squared. So since we're rotating around the y-axis, which is a vertical line, this is going to be a dy problem. So if we look at the shaded region in the y direction, the shaded region exists from -1 to +1. So those are going to be our limits. We're going to go integral from -1 to +1, and then it's going to be pi, and then r squared dy. Because r is horizontal, we can label it with an x. But again, this is a dy problem, so we don't want to leave this x here. So we replace it with the square root of 5y squared, because again, r corresponds to this curve. The other thing I want to point out is if you look at this region, this down here is the same as this region up here. So integrating from -1 all the way to +1 is going to be the same as integrating from 0 to 1 and then timesing by 2. So I'm going to do a couple things. First, I'm going to move this pi to the front, and then I'm going to put 2, the integral from 0 to 1. So instead of integrating from -1 to 1, we're integrating from 0 to 1, and then we just timesed by 2. And again, we're only allowed to do this because this region is the same as this one. If they were different shapes, then you couldn't do this, so that's important to note for future problems. So let's go ahead and simplify this a little bit. We have the square root of 5y squared, and this whole thing is squared. So root 5 times root 5 is going to be just 5. And then y squared squared is y to the 4th. And finally, we're going to bring this 5 to the front. And now we're ready to integrate. So the integral of y to the 4th is going to be 1/5 y to the 5th. I'm going to bring this 1/5 to the front. So 10 pi times 1/5 is just going to be 2 pi. And now we're going to plug in 1 minus plugging in 0. So our final answer is 2 pi. This example says y equals e to the -x. We have x equals -1, x equals 2, and y equals 0. And we're rotating the region bounded by these curves about the x-axis. So remember, y equals e to the x. That graph hits the y-axis at 0, 1, and it goes up to the right. So when you bring in a negative in front of the x, it's going to reflect this graph across the y-axis. So it's going to go like this. So I have that drawn here. Then you have x equals -1, which is right here. We have x equals 2, which is over here. And y equals 0, which is essentially the x-axis. So here's your shaded region. And I drew my axis of rotation arrow. And again, to draw your R, you start on the axis of rotation, you draw it perpendicular to that axis, and you draw it towards the shaded region. And if you look at this diagram, r starts on the x-axis and it goes up to the curve y equals e to the negative x. So over here I have y equals, and then e to the negative x is what we'll eventually plug in for r. Because we're rotating around the x-axis, it's a horizontal line. This is going to be a dx problem. So if you look at the shaded region in the x direction, the region exists from -1 up to +2. So those are going to be our limits. So to find the volume of rotation, we're going to integrate from -1 to +2. And the formula is pi and then r squared. And again, it's a dx problem. Because r goes up to this curve, it's a y value, but because it's a dx problem, it's going to be y equals, and then we plug this in, e to the negative x. All right, at this point, I'm going to pull this pi to the front, and then e to the negative x to the power of 2, we multiply these, so we get e to the negative 2x. In order to integrate this definite integral, we're going to use u substitution. So right here we have a composition of functions. E to the x is the outside function, and negative 2x is the inside function. So we're going to let u equal negative 2x. So du dx is equal to negative 2. Therefore, dx equals du over negative 2. Next, we're going to take our upper limit. We're going to plug it in right here for x. So we get negative 4. Then we're going to plug our lower limit, negative 1. We're going to plug it in right here, and we get positive 2. Okay, let's go ahead and plug all of this in over here. And at this point, I'm going to bring this negative 2 to the front, but when we bring it to the front, it's going to be a negative 1/2. Also right here, our limits are out of order. We have 2 on the bottom, negative 4 on top, so I want to flip these and then bring out a negative. So when we flip these and bring the negative out, a negative is going to make this a positive in front. So now we're ready to integrate. The integral of e to the u is e to the u. So now we're going to plug in 2 minus plugging in negative 4. So our final answer is 1/2 pi times the quantity e squared minus 1 over e to the 4th. All right, guys, thanks for watching.